So tell us a few words about you and about the tool you want to show us.
Sure. Let's see. So, Alexi, I'm Harshit. I am the co-founder and CTO of Chaos Genius. Some background about me would be that I'm a machine learning grad from Carnegie Mellon, where I worked under the creator of CAPTCHA and Duolingo back when I was a PhD student. Also, I work with MIT on knowledge graphs, which is a sub area of AI. And last startup that I created was in the data space. So DeepFlux used by a bunch of Fortune 500, including Disney, which recently just got acquired. And I'm also fortunate enough to be an author of a machine learning book that's used in schools around the world. So that's about me. And what we are doing is Chaos Genius. What we are recently started building is Chaos Genius, and we are like an open source analytics engine. We focus on outlier detection, anomaly detection, root cause analysis, and alerting. A lot of the things also in the roadmap that I'll be sharing. And currently, we are used in 10 plus countries in a variety of use cases, ranging from IoT to gaming, fintech, crypto exchange, and so on.
Yeah, that's pretty cool. Do you have a demo?
Yes. Do you want me to share my screen?
Yes, please.
All right, awesome. So this is Chaos Genius. What you're seeing is like a demo instance that we have, and a few broad dashboards that we have created, say on e-commerce KPIs, cloud monitoring KPIs, some music related KPIs, and ride hailing. What I'm going to do in this demo is first help set up the process on how KPIs are added, how first data sources are added, and then KPIs are added, then walk you through some specific scenarios on the kind of analytics and analysis that Chaos Genius generates for those KPIs, and then we'll talk about alerting. So that's the flow of the talk, if that's okay. Right. So I will first start with data sources. What we have done is you can connect any popular database or data warehouse. We are adding more OLAP data sources like Droid and so on. One. Two, what we also saw was that in certain certain enterprises cases or certain smaller company cases, people may not have the pipelines to pull in their third party data. So when I say third party data, it's data like Shopify or Google ads and Facebook ads. So we have also built connectors for that, and there's a different installation. So that doesn't come in default, but there's also an option. It's in our GitHub repo that you can check out if you want to have connectors for say Shopify and so on. Now, once you select your data source, you are asked all these standard information, and once you test your connection, your data source is added, and the data source is a foundation on which all KPIs and alerts and other features that we have are built on. I'll start. I'll walk you through adding a KPI. So let's say it's a test uh, KPI. We first select a data source. We have a public data source that I have selected. There are two ways to create a KPI. One is a table. A table is certainly good if all the information that you require to set up a KPI is in a table. You don't require any transformation or joins. If you require any transformations on the data or joins, we recommend creating a query. Right now, we'll just select a table. So when you do that, you select the schema. So here, it's a public schema. You select the table. It's just loading all the metadata. And let's say that we are using this ride hailing data, which is the Lyft data. Now, these are the few things that are important when setting up a KPI. So defining what a metric column is, how you want to aggregate your KPI on, what is the date time, and what are the dimensions. So here, let's assume that we are looking at the number of rides and so total rides that we see per day, and date is just date, and dimensions is a very important bit. So that's where all the all the cuts of the data, all the subgroups that you want us to analyze, you first need to define what dimensions are important for you. So as an example here, let's assume that it's Siri, it's a source, destination, period of day of week, and distance, and so on. So once you select all these dimensions and you select a dashboard that you want your metric, your KPI to be added to, then Chaos Genius will generate a set of analysis as to understand what's happening in your data, why things are changing, what's the root cause analysis. So Coming to the dashboard, I'll quickly go to the right-hailing dashboard. So this is the Uber revenue, and what you're seeing at the top here, we provide a series of cuts, but what you're seeing at the top here is something that most BI tools will also give you, right? So what was this data in the last period, in the current period? How is it looking? How did it change, right? And to an extent, if you spend some time, a BI tool can also generate this with some work, that if this was the start and this was the end for my data, these were the key drivers on a very high level dimension basis. But most of the analysis at best is what we have observed is that most analysis in most companies stops here. After that, if you people want to dig deeper, you have to do a lot of slicing, dicing, you have to do a lot of ad hoc analysis, and that is where our drill downs and root cause analysis comes in the picture. So let's look at this data itself, and these were just to give you some context. This is the high level matrix. These are the drill down. Drill downs are either by the dimension that you have sorted, or they are by multi-dimensions. I'll come to multi-dimension later, but let's assume that we are looking at period of day. And if we just look at this, we'll see that, hey, there was a drop in evening, afternoon, and night. There was an increase of 86,000 in morning. And it would appear that morning is doing largely okay. So people would just focus on evening and afternoon. However, if you drill down and really understand what's happening in morning, that is when you start uncovering real insights. So as an example, you see that, hey, even though morning generally was good, but there are significant places where period of day was morning, and the distance was between this range where there was a significant drop. And there are also cases where the time was morning, but when there was particular destination, it increases. But however, when I again drill down, uh, again, when I drill down with period of day morning and source being Haymarket Square, I again see that the overall change which has happened in the last 30 days is 49,000, and that's good. But there was a scenario in which period of day was morning and my distance was within this particular range, and it was Haymarket that there was a dip. Now, what we are doing here, so this is at the high level view, but what we are doing here is looking at all possible permutations in your data and finding and applying some statistical analysis, applying some machine learning to figure out what are the key drivers of change. And at times, these combinations can go into hundreds of thousands. So doing it either SQL or on pivot tables is pretty hard because there's a combinatorial explosion that happens in any such data. So we have
So I was quite interested to ask you that, because like you cannot really try every single combination.
exactly. So we spent a lot of time iterating this algorithms and uh, optimizing the implementation so it works really fast and can scale to an extent. And this starts becoming very important for any enterprise or any company which has a lot of data coming from various sources. And what we also generally observed is that people are just dealing on these high level surface dimensions, but if there is an issue in one of these subpopulations or subgroups, that is often identified much later. It could be months later, or it could be at the end of the quarter that, hey, by the way, this subgroup was a big issue and it was a reason for a drop in this category or this location, but we didn't identify it fast enough. Now, what you were seeing here was just period of day, but you can similarly look at for various dimensions that we are adding. Now, the another feature that we have added is multi-dimension. So what multi-dimension does is that it looks at all the dimensions that we have selected and finds the best reason for this change. So as you can see here that when the distance was, when it was a long distance, right, between 51 and 322, that was the reason for increase. And then otherwise, most of these were a reason for decrease. There is a little nuance to how this multidimensional drill down comes. But before I do that, I'll just walk you through the UI that what you see here is all different subgroups sorted by obviously impact, that what was the impact for this change. We are seeing all different subgroups that were of relevance for a particular time cut. If I select some other time cut, let's say month on month, so I will see a different list of all different key drivers and so on and so forth. There is a caveat. There's a interesting technical caveat around this, Alexi. So if allow me to go on a
Hmm.
tangent for a minute or two, I will do that. If you think you can also
Yeah,
skip
that's
it
interesting.
in the final thing. So the caveat here in this multi-dimension thing is that there is a overlap between this distance and in this case all the things are either distance or period of the evening. For instance, for this distance, the long distance, there would be a bunch of rides which are also period of day which are evening, right? And that is why generating this waterfall is even less non-trivial than a single dimension thing. So what we are doing essentially is looking at the overlap of also a population. So as an example, think of it that if all the long distance rides were always in evening, or almost all of them were in evening, so then we wouldn't have picked it because there was a high overlap between this and this. So we also look at these subgroups and figure out the overlap of the population, take it out, so you get the cleanest explanation from the start to end. You can also remove the overlap and see what the results are if you had no overlap and if you had some overlap. So that's briefly what we have currently in root cause analysis. But and the second bit is anomaly detection. A lot of this analysis, what a lot of this analysis is hard to still monitor on a manual basis. So what people can set up is set up these metrics in an anomaly detection system. What we have in the anomaly detection system is that once you define a metric, you can decide what model you want to run. We have like half a dozen default models. You can also plug in your own model. So if, as an example, you have spent a bunch of time creating time series forecasting models, so that can easily be plugged in by a bunch of hyperparameters and some classes that we provided, and that could be used to build uh, used to identify anomalies in the data. Now, this is a high-level thing which you can still again see in the dashboards now. Some of the tools are also providing high-level anomaly detection, but essentially what often gets missed is that what was the reason and what was all these subgroups that were resulting in this change. So let me give you an example that Uber revenue for this particular spike, I see that. When my source was financial district, when my source was Boston University, Fenway, and when my period of day was morning, these were the root cause for the spike in the data. Similarly, if I look at this drop, I would see that when it was when the source was Backway and Fenway, and when its period was night, that was the reason for the drop. So that is a very quick overview of what you can see in anomaly detection. Also, what we do is give a high level data quality, because a lot of the issues that people face in their business KPIs also can often be derived from data quality. So we give a brief data metric on max, various bounds of the data, count, mean, and missing. And you can see that hey, some of the anomalies here are also related to a sudden spike in count, the daily count that we are seeing, so on and so forth. Also, this is for the overall KPI. What we also have is that if you have an anomaly in a particular subdimension, you can also tap on subdimension and you'll get an anomaly for that. Right now, for the last 24 hours, there is no subdimensional anomaly, so you are not seeing it. But if there, it could be cases that everything looked fine on the overall KPI, but there was anomalies in subdimension, so that will come. Uh, that is briefly about the root cause analysis and anomaly detection for ride hailing. However, this is a fairly horizontal product, as I said. So if I can also show another example where anomaly detection would be more interesting, Alexei.
Yeah, of course.
Right. This would be cloud cost monitoring. So cloud cost monitoring is a little more granular data. So there's a lot of other interesting patterns that you see. Again, this is the standard stuff that you saw here. But if you look at anomaly detection, you see that what was really, and this is cloud cost. So I want to understand that why were these spikes happening and be alerted on those spikes. So as an example, there was a small spike here, and for all these spikes you get a severity score. So we essentially see that my EMR service, there was a spike in my EMR service, there was a spike in my US East region, and there was a spike in my EC2, and they were the primary drivers of this spike. uh, so I think
Where this data comes from? Is it publicly available, or this
some of
is
this data is publicly available for people to try out stuff. Yes. but finally people connect to their own databases in Datafair also.
Yeah, I'm just
Or
curious, like this is an interesting data set with this cloud
yeah.
monitoring.
So this data set we modified with from Microsoft's anomaly detection, Microsoft's anomaly detection data set. So Microsoft has an anomaly
It's
detection
public data
data set
sets.
for, it's a public data set. It's a cloud monitoring data set. So it's modified from there. But if you want, you can, people can try out some of these data sets here. So, we have open source some of these data sets. So Microsoft cloud monitoring data set that we modified. And yeah.
Nice.
So yes, so the subdimensional part I couldn't cover there because there was no real anomaly, subdimensional anomaly there. But here you can see that even though overall is fine or overall is largely fine, there's almost no severity here. On subdimensional level, there are cases that my DynamoDB cost was high or my region cost was high, and so on and so forth. So that is briefly about seeing that from a different use case.
Question.
Yeah.
How does it send alert? Is it email? Is it
Yes.
SMS
So I
message?
was
Or how does it do this?
I was coming to the alert. So now that we are done
Okay.
analysis,
Sorry
what,
for jumping ahead.
no, absolutely. This is exactly what we were doing next. Support is coming soon. So as an example, if it was email, you provide all this information, what your SMTP server is, what your port is, and so on and so forth. Once you do that, we were talking about, I think your question was, how do you set alerts? How do I get notified on changes? So what we do is, let me create a new alert for you. So this is what we call a KPI alert. So let's assume that you want to be alerted on cloud cost. So and whenever cloud cost severely high and so high, and then you select the severity score. So you may not want to be alerted on any minor anomaly, you only want to be alerted on very major anomalies. So you select the severity score where you want this to be alerted on. You select the frequency. It's daily in the slightly older version that we are currently demoing on, but in the most recent version we also have a hourly alerting frequency because we support hourly model runs now. So your message, and now after that you select the channel. So we haven't set up those channels like emails and Slack, but if you have a channel, you select it. Now this is where another interesting part that we came when we deployed it to some of the initial folks is, some folks had ended up monitoring thousands of different KPIs on the dashboards, and then they ended up getting like 30-40 emails per day, which was not ideal for them. So what we have done is added an option for consolidated alerts. So what that does is that all the alerts that you received in the day or in the last hour, you'll get as a bulk either on Slack or email. And you also get like a dump of the data so you can explore and understand what's really happening. And that becomes really important if you have like set up a large number of KPIs of this. So that's pretty much it, very briefly about what we have right now. And one thing that we didn't cover here, or most of the things that you saw here uh, were analysis on a particular KPI, let's say, right? So for a cloud cost, my analysis on cloud cost, for my ride hailing, my analysis on ride hailing. But often across an organization, your issue can happen in some new deployment, and that new deployment can lead to your business matrix changing, right? Or it could be your marketing spend was high, but it was in some other category, which led to your reviews going down. Now, that is like what we call cross KPI and cross event root cause analysis. So that is what we don't have currently, but that is something we are building, and that is also related to shallow causality. We don't think that we can handle deep causality because there are a lot of counterfactuals, there are a lot of uncertainty around it, and it's just a more open problem. But we do giving people access to shallow causality for all the KPIs and events across the organization makes this a lot easier. So yeah.
Yeah, that's pretty cool. And that's a lot of work, right? So right now this thing is not running on your local host, is it not? It's some
Yeah, it's some server.
like
Yeah.
Is
But
it difficult to run it on local host?
not at all. Not at
It's
all.
like Docker Compose up or something like
It's
that.
just Docker Composer. So I'll just walk you through this. It's just get load.
Yeah, cool. And that's it, right?
That's it.
That's all you need to get started.
And I think I mentioned the third party stuff. So if you want Shopify and Bing ads and all this, then instead of Docker Compose up, you did Docker Compose third party.
Mm-hmm.
And why we have segregated that is otherwise your default installation gets too big. So that's a larger installation with all these guys.
How many people actually work on this? Because I imagine this is a pretty big project, so there
Yeah,
must be
it's
multiple
a
people.
little over 10 folks who are working full time on it, our internal team. And then we have been fortunate to have a bunch of variety of contributors across the globe who have helped us with the code, everything from code fixes to issues. And so we have around 10 serious contributors right now. And a lot of people are trying out the product and giving feedback.
Yeah, that's the benefit of doing things open source. People just go and help you, right? How old it is, the project?
It's a few. We open sourced just 3 or 4 weeks back. We started building it like it has been a few months since we started. But we open sourced
Yeah,
in around 4 weeks.
it's quite a progress. You said it's like a few months old, so you did quite a lot in a few months,
Yeah.
and then open source. That's
Yep.
amazing. So I think you briefly talked about your plans.
Yeah.
Do you want to say anything else, or what is
Yes.
it
Absolutely.
else? What
Absolutely.
else is in your pipeline?
Right. So the broader roadmap that we have, Alexi, is like every analysis that an analyst, a business analyst, and a data analyst has to do, or whatever is in their workflow, that could be improved or automated. We want to build all those features into Chaos Genius, right? So right now we just have multidimensional drill downs and insights, but we want to do more deeper root cause analysis, forecasting, seasonality detection, whatever analysis. So there are a bunch of things that makes all this analysis complete and makes it much easier for especially a non-technical business user or non-technical analyst, but even makes it more smoother for an analyst. So that is one thing that we are working on. That's more on the feature bit. Besides feature bit, what we are also doing is adding support for more data sources, adding support for larger data. So as you can imagine that there is a certain size, and for certain analytics, even cloud warehouses like Snowflake and BigQuery are not enough, and people use stuff like Druid and Pinot. So we are adding support for data sources like Druid and Pinot. So that's one. The other is that some folks are having both thousands of KPIs on our system, and some of those KPIs are also querying like at times billion records, or are spanning over a billion records. So we are adding support for both larger data as well a lot of KPIs with horizontal scalability. So we right now don't have the default Docker Compose. There's a lot of horizontal scalability that's baked in. So that's another. And then essentially the third layer is that there are a lot of access control and auth features that people ask when they deploy it in larger setups. So that is something that we are also building. But in the context of data, these are some of the few things that we are trying to tackle. And the broader idea is that everything that could be, everything that could make life easy for an analyst, or that is automatable, we want that to be a part of it.
Yeah, that's pretty cool. So I think we're out of time, so I'll jump to the last question. Is do you have any advice to anyone who is watching this?
I think so. What we found surprising is that how many people don't spend enough time on observability and baking in observability, especially for their business KPIs, but also at times for data infrastructure. And whenever they have used Chaos Studios, they have found a lot of uh, uh, interesting business leakages that were happening that could have been prevented had they used Chaos Genius or set up some other tool, or build something internally. And that could be both pretty useful in terms of the business impact, but also makes life easier for data infrastructure teams. So generally, both for business and generally, I think doing observability sooner is better.
Okay, makes sense. Yes, and of course, go check Chaos Genius. Give it a star. How many stars do you already have?
We have 297 stars, but it's just been 3. We only
Not enough, so it definitely deserves more stars. So if you're watching this, please go to GitHub repo and give it a star. And with that, I think we should be wrapping up. Thanks a lot. We will add on the links in the description. And yeah,
thank you,
thanks.
Alexi, for having us, and look forward to hearing a lot more talks from you and